Since Jonathan mentioned chktex, it's also useful to know that there's another tool for lacheck called lacheck, which I suspect is in TechLive, although we've had it installed in our system for so long, I don't recall where it's found in the search path. The problem I found with chktex is it complains about too many things. There are too many red herrings appearing in the output, so you get lots and lots of warning messages, most of which you could ignore, and lacheck does a somewhat better job. For BibTeX, I have my own tool, BibCheck, which is available on the web, that attempts to apply heuristic rules for common syntax problems and catch errors. None of these really purport to be complete parsers of the languages. One thing that Jonathan didn't mention, I'm sure all of us here know, is that TeX itself is an extremely general system, as is SGML. In both languages, you can redefine the meaning of any character. And so, although one is used to seeing HTML and angle bracketed markup, you could choose any other delimiter you care to, and it would still be valid HTML with a suitable grammar file. Similarly with TeX, one can redefine the meanings of brace codes and escape characters and so on. And that makes things astonishingly difficult, because if you were to handle documents like that, you really have to parse everything that TeX can do. And as far as I know, TeX and Doug's JS box are really the only parsers we have for TeX with full generality. On the other hand, one can observe that almost all TeX and LaTeX documents in the world never touch cat codes, never change the meaning of individual characters. And so one can assume that when you see an open brace, that there should be somewhere a closing brace that matches it. And then you can do something sensible. And so I have a TeX Pretty printer called TeX Pretty that tries to clean up LaTeX input that's been carelessly formatted. Now, I myself am extremely finicky about what my LaTeX input looks like. And so I really need this tool, but I also have to deal with students who come in with 5,000 character lines with an error on roughly character 4,900. And that's all TeX has told them, there's an error on this line. So we have to get that text reformatted in something manageable. And so that can be sometimes done if it's not too big in Emacs or any editor that's got some sort of an autofill capability, or with TeX Pretty. For HTML, Jonathan in his email mentioned HTML tidy. Back 25 plus years ago, I wrote HTML Pretty, which has been in constant and daily use here, and has been used millions and millions of times on HTML files. I have a tentative extension of it for XML, although XML is somewhat more problematic. One of the issues is that although SGML was originally designed to be a rigorous, albeit rather peculiar grammar, HTML borrowed the look and appearance of SGML, but dropped the grammar. Now, the Web Consortium, of course, has developed several generations of HTML grammars, but the reality is that the vast majority of HTML pages on the web do not conform to those grammars. And browsers do not use a grammar in parsing the HTML. They simply look for tags that they know how to deal with and ignore anything that they don't know how to deal with. So they recognize a paragraph tag or a level 1 header tag and so on and do something sensible. And people are satisfied because they get what they expect. But the file may still nevertheless not be grammar conformant. And you can input an HTML file to a browser that has a header level 3 tag before a level 2 tag, which doesn't make any sense logically, but it will typeset it or display it on the screen in some form. What XML does is require that there be a grammar file, and that grammar file has to be declared at the beginning of the document. And that grammar file defines what all of the tags in the document mean. And this, of course, then means that there isn't really a standard set of tags for XML files. It depends on the grammar file, and that can vary from publisher to publisher and site to site. Whereas with HTML, people more or less agreed on a set of a few dozen tags, and we don't introduce any new ones. So this is a big mess, and the best we can really do is apply heuristic tools to help fix up some of the problems. So pretty printing code to have a uniform regular layout certainly helps. Having heuristic checkers that look for common problems is also helpful. And those problems need not necessarily be related to syntax, but could be with respect to content. As an example, it's common in parts of the English-speaking world for multiple generations to share a common name. And so you will have Henry Ford II, Henry Ford III, and so on. Or you might have Henry Ford Jr. and Henry Ford Sr. Well, the common convention in English is that if it's a Roman numeral after the name, it doesn't have a comma between the family name and the number. But if it's a junior, senior, or PhD, comma, or SJ period, any kind of titles and so on, then you do have a comma. And people routinely mess this up and get it wrong. And the syntax checker can catch things like that and complain about it. And so my bib check does exactly that sort of thing. Anyway, that's all I have for the moment to comment on.
Well, thank you.
I had a question. You said there's no formal specification for LaTeX syntax, or is that because it's impossible, or is it because nobody's done it?
The issue is that LaTeX was built on top of conventional tech, that is tech without cat code changes. LaTeX itself internally does make cat code changes, notably the @ sign, which is normally not a valid letter, is made a letter so it can be used in control sequences that the package writer can use that don't conflict with user-defined control sequences. But David Carlisle, probably 2 decades ago, published a very interesting tech file. It's not very big, and when you typeset it, it produces a lovely looking poem, but the input is just totally gobbledygook. It looks like an encrypted version of a random stream of bytes. And he does that by fiddling cat codes. So with LaTeX, the Lamport book and the LaTeX companion make little mention of category codes and just assume that standard category codes apply and that braces mean what they conventionally mean.
I understand that, but I'm talking about the the part of LaTeX that faces the user, that faces the student, that faces whoever. Is that something that can have a formal definition, so that there are tools that can parse LaTeX to create other types of output?
Well, again, because LaTeX is not grammar based and tech itself really isn't either, the problem is that LaTeX will look for markup like begin document, document class commands, begin math, end math, and so on, and attempt to do something sensible with them. It doesn't know that you can't, if you're in a book style, you cannot have a section that is not inside a chapter, because there's a definite hierarchy of chapter, section, subsection, and so on. LaTeX never enforces that because it can't. It can't parse the entire document. It has no notion of a grammar for the document, and nobody's ever published one, to my knowledge. There's an assumption that you do conform to the grammar in your input, and you're told that you might get funny output if you don't conform, but it doesn't catch the error. Now, a pretty printer would show up things like this, because one thing that pretty printers for almost all languages do is when they find an object inside another object, they indent it. And so the visual appearance reflects the logical nesting. And if you have things like a chapter inside a section or other things that are out of order, you'll get very funny looking indentation. That should be a sign that something has gone seriously wrong.
I'd like to say a couple of things on this. First relates to HTML, which is actually a very interesting feature, which is quite opposite to what's happening in LaTeX, which is why I'm going to tell you about it. So HTML has a concept of document type definition, and there are rules about what can be included in what. And the nature of the rules is quite specific, and it does not use regular expressions. The rules are rather different from that. It does not use regular expressions. And one of the reasons for this is the following. The validation, if regular expressions be used, would require matching for regular expressions. And it's quite easy to create a document input to a regular expression that constitutes a denial of service attack. And it's quite difficult to prevent that thing happening. So the DTTs of HTML are such that denial of service attacks can't occur. I suppose it's hypothetically possible that for text typesetting, you could create a paragraph that constituted a denial of service attack. I don't know if that's been explored. But the philosophy of HTML, which was developed at IBM, which may be significant, the philosophy of HTML is that documents will run successfully. And one of the purposes of HTML is that if it's a valid HTML document and the document process fails, then there is a fault in the document processor. That's the general view, that's the strict view regarding validation, that if the input is valid, you will get valid output. And certainly that's what happens with programming languages, that if your input is semantically valid, and that can be checked without compilation, then the output will occur. Whereas with LaTeX, well, you can use random numbers. The date and time are random numbers, and the year. So you might say cat code month equals day, or rather the other way around. Cat code day equals month, and that will just play havoc and change things.